I'd like to talk now a little bit about another really important reason why liquid and air are not mutually exclusive, and that there's going to be, they're going to coexist. There's two reasons. One is that not all equipment can be liquid cooled, and then so there's going to be some equipment that is outside of a liquid cooling solution that's not going to be in immersion, or it's not going to have direct contact liquid cooling. So it's just not included in the liquid cooling solution. And then there's equipment that, even though it can be liquid cooled, not all of the heat is picked up by the liquid. Some of the heat is picked up by the air. So just looking at the cabinet level in this slide, this is for a cabinet that is liquid cooled. How much of the heat is picked up by liquid and how much is left to be picked up by air? So we have the different types of cooling. Immersion cooling picks up all of the heat of the equipment that is in the tank, leaving nothing needed to be picked up by air. The two forms of touch cooling, direct contact liquid cooling, somewhere around 65 to 75%, and these numbers are increasing as these solutions are refined. Somewhere around 65 to 75% of the heat is picked up by the liquid, leaving 25 to 35% of the heat to be captured by air. The fixed cold plate solution picks up 93% of the heat, approximately, and this is the result of an independent study done by NREL, leaving 7% of the heat to be picked up, to be dissipated in another means. This is such a small percentage that in a fixed cold plate solution, no fans are necessary. So the liquid is picking up the bulk of the heat, and the rest of the heat just kind of convectively or conducts out through the cabinet and is picked up by the ambient air. So no fans are required for this solution. In many of the direct contact liquid cooling solutions, fans are required, but they're running at a very low speed, so they've really benefited from the fan affinity law, and they're using a very small fraction of the energy that was used when they were a full air-cooled solution. So with the close coupled air cooling, rear door heat exchangers, and in-row cooling, none of the heat is picked up by liquid, not from the source. So those are not actually liquid cooled solutions. 100% of the heat is being picked up by air, and then it's giving that heat to the liquid. Then if we look at the room level, we talk about, well, okay, so what components, what types of equipment is a good fit for liquid cooling, and which is going to remain sitting in the room requiring air cooling. We look at compute processing, chips, and switching and solid state storage, spinning media, power supplies. All of these things air can do quite well because air is so flexible. It can go in and around just about everything without causing any problems. So we won't talk about that. But for touch cooling, the processing can be easily done by both touch cooling and immersion. Switching with lots of cords and ports, that becomes a bit difficult. It's in development, but it is a challenge for both touch and immersion cooling. Solid state storage can be cooled by both solutions. Spinning media is something that can be done by touch cooling. For immersion, that spinning media needs to be sealed. It needs to be a helium disk drive, a sealed drive, so that no liquid can get in through the vents that are in some of the hard drives. Power supplies, again, air can handle that, of course, and it's in development for touch, and it's something that immersion cooling can handle. So this is why you're going to have still some air and some liquid cooling. regardless. Not everything is a fit for liquid-cooled solutions, at least not yet.